So what did you have to do for the Reddit challenge?
I had to go to their Reddit, their subreddit.
So you probably look up like integrity, right? And then their subreddit. Go here, boom, right there, right?
Yeah.
And then you scroll down a little bit. Wasn't it in like their comments?
Yeah.
But obviously, one of their challenges you just post it, and then you look on one of the little comments. This one has 2 comments. Boom, yeah, something like that, right? And of course, the Twitter was the same thing. The first section that we're going to focus on is the warm-up section, right? First challenge being simple hash encryption. So this was a challenge, right, on the warm-up section where you have this hash from encoding, right? You have it as encrypt.txt. So here's the challenge with the encryption, right? You have this hash. And honestly, when I first started doing this, I was like, okay, what kind of encoding this is? I don't entirely know what kind of encoding this is for the challenge, so I decided to go to CyberChef instead. And what's nice, does anyone remember what CyberChef was? How nice it is when it comes to hash encryptions?
Very easy. I used it.
Yes, so obviously you have a hash and automatically, most likely 9 out of 10 will know what kind of encryption that is. So obviously this was a base 32 encryption. And look, now it says, okay, it's a Morse code encryption. Keeps going down. Went from Morse code and into hex, right? If I get rid of this really quick. Now it's in hex. Decode from hex, decode from base 64, and then we have the hash. And we have the plain text right there. Next challenge we had was also the flag.rar, right? This was the one that Sam was doing, right? So we go into this file that we have, right? To unrar a file, to extract the contents of a rar file, you have to install rar first, use the E parameter, and then your file. Obviously, this had multi compression methods installed on it. So you'll do tar and then xvf to just keep unencrypting it. So boom, right? You do it again, right? It had another encryption method on it. So you do the same thing. Same thing, xvf, and then flag b2, right? And then I had it again. So you do it again. Right, you just keep doing it. Unfortunately, there isn't like a recursive method, right, where you can just keep uncompressing all this. So you just had to run this a few times. I tried looking up, I couldn't find one. So maybe there is. I couldn't find it, right? Unless you make your own program. Like you can make your own program to recursively uncompress all of this, but it's just kind of easier to just do this. Then you have a zip file, so unzip it, flag.zip, and then we have the GIF file at the very end. So one thing, if you don't want to just run strings, you can run like multiple things. You can use, what was one website? One website to test kind of encryption methods for images. APRISOL, you guys remember that?
Nope. No. I remember I used it. I don't remember the name.
So of course APRISOL, what? No, not entirely. Right? Runs strings on it, runs hashing encryptions on it, runs even.
You use the same thing on the terminal. You don't need to go into different websites to do that.
Well, yeah, but like, it's just very quick because it uses all these tools. In my opinion, it's quicker running than strings and then like exif tools and then all this other jazz. Right? I could just find my file and then it'll just do that automatically. And obviously, if that doesn't work, most likely it has some other method of encryption. So of course. Just find the file really quick, right there, upload that, submit, and then when we get here, it of course has some views where it changes like, basically like having a filter for different kind of image colors, right? Sometimes if you might find a CTF challenge, the flag might be hidden inside like a small color mapping. So then you just use this kind of color mapping to find it or whatever. But right here, right, if we just go to strings, boom, we can see the flag right there at the very top. Sam was able to solve this, even though he had one thing, of course, if there were strings, right, the problem what he did is he ran strings on flag.gif, right, and obviously it teleports you to the bottom. Now you can scroll, right? But obviously if you guys see to the far right, You see how far my,
He's-
yeah,
that's fine.
taking a while, of course, you
All the
know,
way up, like,
yeah, but obviously,
All the way up.
let's say, for instance, the flag was in the middle, like right here, for instance, right? Then, of course, what could we use to just filter out our strings? grep, right? So flag.gif, right? Grep, and then just, I don't know, int, because the flag format had that beginning part over the wire. Yes, okay. So now it's over the wire. So these challenges were a little interesting. We actually didn't solve it during the time that we were doing it. We needed to stay inside our TCP packets of FTP, those transfer file packets, right? And one of the packets actually had the file, the flag.txt.
you're joking.
Yes, so I'll show you that. So Wireshark,
I pulled this in.
pull this in. That's kind of what happens usually with these CTF challenges. You kind of have to learn and find that maybe we're always overthinking it, right? And we need to take a step back. So obviously, it told us in the beginning it was using an unsecure protocol, which was FTP. FTP is unsecure as it doesn't use any sort of encryption. It's all plain text, right? So we'll go here.
I think I know what I was doing. I was chasing the password.
Yes, so the
That's
problem is
why
that, you know, thing that Sam and I were doing is that we were trying to find a way to actually get into the FTP service, right?
Yeah.
But what's unfortunate is that you can't because the destination, which is 192.168.16, is a local machine, like our network, for instance. Like you guys can't connect to Marienville.local if you're not on, you know, or on the campus. You know, if you're not here locally, you guys can't connect there at home, for instance. So that's why you're not able to connect to this. So of course, we'll follow our TCP string. We can see, boom, right here, right? We are seeing the transfer of data, right? They enter a password, they log in. We see right here that they're exchanging a file, and the file is called what exactly? Flag.zip. And what's interesting is that if we continue more, right, we'll be able to find the packet where that file is being transferred. Try to find packets that are short, like this, and packets like these as well.
Especially if they say flag.txt.
Especially if they say flag.txt right in the middle. With FTP, right, everything is stored as plain text, as I said before, which means that the flag or that the files being transferred are also in their plain text encryption. But
send it to Chef and then it's
well, you can't put it into CyberChef because you need to convert it into a flag or into a file, right? So what you can do is, let's for instance look at the hex dump, right? We see the address, we see the hex, and then we see the characters on the far right. This hex right in the middle, right? You see this hex in the middle? That's the contents of the file. Let's say, for instance, hex dump challenge and then -c, right? We can see our hex right here in the middle, and that hex corresponds to contents of that file. So what we have to do is we have to go to here, copy our hex values, put it inside a hex value to file decryption, right? And then we get the contents. So another way to actually just view the hex is to view it as raw. So I'll view it as raw, and then I'll look up a source like hex to file, for instance, right? I used a different source than this one, but you can use this one. Yeah, I tested this one. This one also works. We specified hex string, and then does anybody remember what file we have to? Now this part's important. What file name do we have to put for?
Flag.txt.
Not flag.txt. What was it originally for when we transferred it? What was it? Flag.zip, you said? Yeah. So flag.zip. So we have to convert it as flag.zip. We get our file.
and then you unzip it and then you copy it.
Yep. However, there was also a password, remember? Password for the zip.
I was going the right way. I'm hiding.
That's why we needed the password, right? That's why we needed the password. Okay. So obviously we have this zip file. I'll do flag or unzip the flag.zip, right? And obviously we need a password. Yeah, there's our password. Now, what's actually another interesting thing that they decided to put on it is that the password won't work because if we go a few packets forward really quick, they send a message, right? It says, hi Kat, this flag is really important, so I had to encrypt it in case it falls into the wrong hands. You already know the FTP password, which was the super secure 2022 thing, right? Just use the same here, but update it accordingly. Now, when we go back to that packet, right? What's the password? Super secure password 2022. What year is
Change
it?
it to binary because it's saying it's changing it to binaries now.
The
2023.
yeah, the year is 2023.
Oh my.
Do the same, right? And then change that one. There we go. Okay. So obviously it's not shown because passwords aren't shown when we're entering the password. Do ls, and then we have the flag. Oops. Boom. There we go. If only there was a secure FTP, which there is. Does anybody know what it's called?
FTP2.
FTP. And does anybody know what the S stands for?
Secure.
Secure. So secure file transfer protocol. Okay. Our next challenge, of course, is over the wire part 2. So I'm going to go back to that. I'm going to go to integrity or whatever. I'm going to go into warm up. And then I'm going to actually exit this real quick. Okay. What's interesting about this one is with secure file transfer protocol, everything is encrypted, right? So not everything, but when you're transferring files, right? Not text messages or anything like that, or not text messages, but sending text via text through SFTP, but through files, right? The files are encrypted. So what we're thinking that we're going to have to do here is we have to find a file on this, right? And basically decrypting it. So I'm going to follow the TCP string, right? And we'll see if we find anything good, right? There we go. Okay, here we go. Image, right? We have the file's names, the file's contents. Image/PNG, name equals image.jpg, right? And then what's the encoding type?
Base 64.
Base 64. Now you'll see that it's a lot, isn't it? So I really haven't found, there isn't really an easy way to actually just, copy all of this.
Copy all of it.
Yeah, you gotta copy all of this because the next thing that we're going to do is we're going to say from base 64 to file. So I'm just like holding down and copying it until we get right there. Copy that bad boy. And then from base 64 to file, something like that, right? We can paste in our base 64, decode the base 64 to a file, and then boom, we have this cat image right here.
You want me to string it down?
We're actually going to run it through Ipresolve, right?
Yeah.
As there's going to be
I'll string it anyway.
Yeah, sure. You can string it. Might be something you might find in the string, right? Cat. I'm going to name this as cat image. And then I'm going to go to Ipresolve. I'm going to upload a new PNG. Let's see here. Downloads cat image.
There's nothing.
Yeah, this is why I like using Ipresolve though, because there's a lot of stuff that can extract it, right? Like most likely there's not going to be strings or there's not going to be some sort of encryption type, but Ipresolve, it's going to find all of that. It's going to find all of that. It's really neat. I think with this image, it was actually in, let's see. No, it wasn't inside the metadata. Oh, it was in stake height. There we go, right?
Let's go.
See, like, that's why I like using Ipresolve, right? I mean, how would you know it would have been stake hide or z-stake hide or it was an outguess? The extraction, the metadata, for instance, or you have to use binwalk, download the files in binwalk. I mean, this is why I like using Ipresolve. It's all there. It's all clear. And then, of course, just look through it, and then, boom, we're able to find our...
hidden crypto cat.
We're able to find our hidden text with stake hide. The next challenge that was on the CTF was open source intelligence, right? that open source intelligence image was called picture.jpg. And for this challenge, we had to find the author's location using this image right here. To start, when we look at the image, pictures.jpg, the author's name was inside pictures.jpg in the metadata. So we run exhibit tools, and then we could see, well, there's the author's name right there, but if we go up a little bit, right? Creator, right here, on creator's line, it is flip-flops, right?
It's flop.
No, flop, whatever.
It's flop.
Well, okay, so that's the creator, but that's not the original creator. What's interesting, that's not the original creator, and we don't even find their location there. So one thing you could look on, one thing you could look on for multiple social media platforms that a username is hosted on is a tool called Sherlock. So we run this tool Sherlock on that username, and it shows us that hey, there's an about.me page. We run it a little bit more. It says some other jazz as well. And this is, of course, the blog that you get, okay? And this is, fortunately, the last place that you have to go to. But what's interesting about this is that
you have to go to another user.
No. It's that you don't, the information isn't present there, okay? So one hint that they give here is I don't think it's a good idea to share your location online. So what we have to think is that at one point...
Now we gotta go to the time traveler.
Yeah, time machine. Well, there's a website called Wayback Machine that we can use to go to a previous point on the internet, right? A previous point of when this session was saved. So at one point, they posted their location. They decided to edit it to get rid of that location. And now we have this. So what we do, go there, type in Wayback Machine, right? And then we can put our URL into the Wayback Machine to find at a different point of when they decided to change the whole blog. So obviously we can pick a moment like, when was the challenge posted? Yeah, I'm just gonna go to November 21st, or we could go to October. So November 21st, that's when they changed it. Okay, let's go to October instead. We go to October, and
That's terrible.
and we see, okay, look, I took this picture when I was at, and then there's a flag. So the way that, does anybody know what a RSA? What's funny is that the description had really secure apparently, and when you actually abbreviate that, it's RSA. You guys remember what RSA was?
No.
No? All right, let's look at this little picture here.
It's when you give a public key and then you get the private keys and then you change the paint.
Yeah, you have both private and public keys to use together to unlock the ciphertext to get the plain
on
text.
a color and then you
No. That was stored for the representation, and here we're using numbers now, right?
Yeah, I know, but like.
Yeah, for the
that's how I understand.
Yeah, for the demonstration they used the colors, which was really lovely, and then they used numbers using mod, right? The mod function. So obviously RSA is really unsecure when you have when you have really small numbers, and pretty secure when you have really large numbers. What's interesting about this is that it's actually not a really big public key. Like it's not big enough to say it's unfactorable. So what that means is when you're trying to factorize a public key, you're trying to find two values that will equal your private key, right? You have those two values, you can multiply them together, or no, it was, I think modular them together or something like that, right? And then that's how you can get your private key. You get your private key, you can undecrypt your ciphertext. Okay, so this is really good. You can have your public number, right? Factorize. You get your two private numbers, which are here, They have 155 digits in between them. Multiply them together, you get your public key.